Hello, good evening or maybe good morning or good afternoon depending on where you are and when you are. Welcome back to the course on electronic packaging and manufacturing. So, today we start a completely new topic and that is second level packaging. So far we had been talking about first level packaging where the focus was more on the attachment of the chip to the chip carrier or the substrate that we talked about. Okay? And we did talk about a little about the attachment of the package or the substrate onto the motherboard, especially when we talked about pin grid array, ball grid array, land grid array and so on. Now, the thing is what happens thereafter? Okay, your package now goes on the motherboard and then the signals actually get transmitted or transferred through the motherboard, right. So, therefore, the question now arises and which leads us to the next level of packaging is what is the anatomy of the motherboard and how do you fabricate the motherboard? What are the design parameters of the motherboard? So, these are the things that we are going to discuss as part of second level packaging. Okay. So, today the contents that we are going to discuss today is printed circuit board or PCB. We will look at what is a PCB, okay, what constitutes a PCB, and then we are going to look at anatomy of a PCB. How does a PCB look like? Okay, what is there in the PCB? And finally, we will get into the manufacturing side starting with what are the circuit board materials. Okay. So, with that introduction, let us get started on the discussion about printed circuit boards. Okay. Printed circuit boards or PCB, which is the most commonly used term, however, can also be denoted by several other synonymous technical terms. Printed wiring board, that is also used very commonly, or PWB, CCA circuit card assembly and PWA printed wiring assembly. So, these four terms and acronyms are used widely, okay, across this industry and most often they mean the same thing. Okay. So, circuit board, if that is the most broad term, the circuit board is a major element in the mechanical design of an electronic system. Okay. So, if you think about it, I would say it is a circulatory system of the electronic product. If you look at the equivalence with the human body, you have the brain, okay, that gives us our thinking power, that generates the signals, and thereafter what happens? You have these two systems, the nervous system and the circulatory system. So, you can think about one for transmission of the signals, the other for submission of blood, correct. So, for circulation of blood, I am sorry. So, these are both extremely important. So, you can look at the PCB as one of these systems and let us say it is a circulatory system. So, this is what is carrying the signals and carrying the information from number one from the brain, which is your microprocessor, to the other components in the system, okay, and also bringing in the signal and power from an external source onto the system. Okay. So, motherboard's function is of paramount importance and that is primarily the medium through which the signals get transmitted and transferred and communicated. Okay. So, if you look at these functions, what does the motherboard do? Well, number one, of course, it is a substrate where you mount the components, whether it is your memory, whether it is your graphics, whether it is your CPU, whether it is your controller hub and various other things, the passives like capacitors, resistors, inductors, the MOSFETs. So, all of these actually are attached to a motherboard or a circuit board or a circuit card. Okay. It also has a soldering pads for first to second level and second to third level connections. Most importantly, it has the wiring paths. Okay. These are the wiring traces or wiring, as we will see later. These form the paths for chip to chip connections. If you have multiple chips on the same motherboard, how do they communicate with each other? That is through these wiring traces. So, these are the communicating paths or communication paths between the different components that are sitting in the motherboard and which constitute the system. Okay. Circuit board is also the test bed and points for circuit checks. Okay. So, this is where you also see if once you attach all the components, what is working, what is not working. You looked at the ball grid array, the pin grid array, land grid array. There are hundreds and hundreds sometimes 1000 IOs, right. In BGA you can have 1000. LGA, we talked about the LGA 771, which was one of the first major LGA applications in the computing industry, 771 interconnections. Now, which one is functioning, which one is defective if at all, how will you determine that? So, it is through that circuit bed actually gives you the the means of doing this tests and checks. Okay. And finally, it is also the marking surface for identification of components at assembly. Okay. So, circuit board many a times has these letters etched or the numbers etched. So, that is a marking system that is followed, and that helps you to identify which component is there or what is that design or what is the circuit board designed for, which component. Okay. So, part numbers can be written or etched on the circuit board. All right. So, therefore, it is one of the major and most important components in an electronic system. Okay. We also talked about, if you recall, we talked about chip on board. What is chip on board? These are where you do not have a first level, where you do not have a chip carrier, the silicon is directly mounted on the motherboard. Okay. So, these are all the things. The printed circuit board has, that is a very essential component of any electronic product or system. Okay. Well, the other thing that we want to talk about is another name that is often used is the motherboard. So, motherboard is probably many a times very loosely used, but that is like the big board which is the main circuit board for a system. And then onto the motherboard you can have smaller boards attached, which are many a times called the daughter boards or daughter cards. Okay. A very simple example is, if you look at your desktop or laptop, you have a big motherboard with a lot of components, and then sometimes you will have these connectors for these memory cards, okay, which are circuit cards or daughter boards, okay, which will have this, that is a much smaller piece of you can still call it a printed wiring board or printed circuit board with limited number of components. So, in this case memory, for example. Okay. So, we see these as well. So, motherboard that way is sometimes, though many a times loosely used, it is typically unless otherwise stated, it is the primary circuit board that goes into a system. Okay. All right. So, if that is the case, let us move on. So, this is a picture of the circuit board. This is a picture of a circuit board before components have been mounted on it. So, you see you have this connectors at the edges, right. So, these are the input output ports to the circuit board. So, one thing you can see immediately is the fact that when we talk about a chip and a chip carrier, there are probably hundreds of interconnections, but then what comes out of the circuit board is definitely a much lesser number. There is a lot of interconnection between the components, etc., but finally what comes out or goes into the circuit board is a far lesser number of connections, and that is what you see here. So, each of these these markings that you see on the connector, these are one of the channels. Okay. So, these are each one interconnection, but and then if you look at finally what happens. So, circuit board then goes into the third level packaging, finally it is a system integration, and finally what do you give to the system? How many IOs come in? Just 2, because it is a plug that you plug in into your wall socket. Okay. So, that is primarily 2, and probably sometimes you will have the earthing as well. All right. So, if you look at this circuit board, let us spend a little bit of time over here. This is, as I said, this is just the circuit board or the circuit card before the components have been mounted. So, what do we see here? We see a lot of these connection points. If you look at where my cursor is right now, what is this one? This is the place for connection of a quad flat pack package, right. You remember the quad flat pack in first level packaging, where you had leads, typically let us say a gullwing type lead that is coming out, and that gullwing, the other end of that interconnection or the lead will be connected to the circuit board as we had discussed at that time, and now we see that. These are the points where those interconnects or the leads are going to be attached. Okay. We see another one here. Here you see, for example, where my cursor is, many of them, these are like dual inline packages. Here, these are all dual inline packages. And then you also see these are all surface mount technologies. So, the mounting pads or these connection points are on the surface of the motherboard. But however, look at here where my cursor is right now. Okay. Or let me try to use this pen. Okay. So, this is, I'll just go with the cursor. Look at here, these are through hole points over here, you see. These are for through hole components. You can see these holes on both sides of this component that is going to come here. So, these are leads that are pin in hole arrangement, these are not surface mount. Okay. So, that is why you have these holes, the inner surface of which is metallized, so that the connection is made, electrical connection is made. Okay. You see some of those other points here as well in many places. So, this is a circuit board, not a very sophisticated one or not a very dense one, but this you can see the number of components that can be mounted on a circuit board. If you count 1, 2, 3, 4, 5, 6, lots of them, 7, 8, 9, 10. So, lots of them. A circuit board has multiple components attached to it. Okay. And here we see a combination of components that are surface mount and also components that are through hole. Clear? So, that is a circuit card or circuit board. So, now let us look into the anatomy of a circuit board. What is a circuit board made of? This green thing that you see, sometimes green is the most common, but sometimes there are circuit boards that are red in color. If you just do a Google search, you will be able to see, of course, primarily you will see green, but sometimes you will see red in color. Sometimes you will see yellow in color. Okay. So, this all depend on what is the material that is used. Okay. So, therefore, that brings us to the picture, what is a circuit board? Okay. And you may be wondering that if I look into this picture before, okay, this connection is made over here. If I take this package, okay, the leads come and make the connections on the wire board, but then what? Where are these connections going? I do not see any connection between this component and this component. So, where is this connection taking place, right? So, that brings us to the anatomy of circuit board. So, circuit board is a laminate with copper cladding on one or both sides. Okay. So, once again we will look into this later. A circuit board is made of a laminate material, laminate as in different layers, and it has copper cladding on both sides, and sometimes the copper cladding is also removed. We will see that. Okay. Now, what is this laminate made of? It can be a glass cloth, it can be a cotton fabric or paper reinforcement in a polymer matrix. Glass is the most common, glass cloth is the most common. Okay. And sometimes if you want very rigid and hard boards, the thermosetting polymers are used. Not sometimes, I think it is very common these days. The thermosetting polymers are used as the binder. So, that is what holds this glass cloth fibers as well as this copper laminates that we are going to talk about. I am sorry, this copper traces or copper claddings that we are going to talk about. So, once again the laminate consists of a glass cloth, most commonly a glass cloth, and which is in a binding material. The binder is a polymer matrix. Clear? So, depending on this what the laminate is, sometimes what is most common, we will see this later, we also call it an organic laminate depending on what is used. The compound used is an organic compound. Okay. The other thing that we will talk about here, types of PCBs. Okay. So, what are the different types of PCBs that we know of? So, the first one is single side plated. So, components only come on one side of the motherboard, or sorry, one side of the circuit board. So, single side motherboard is a common example where components are placed only on one of the sides, let us say the top side. So, for example, if you go back to this picture, the components are probably on one side, we do not know what is behind, but from here it looks like the components are all on one side. Okay. So, if components only come and get placed on top of this motherboard on this side that we see, then it is a single sided motherboard. Now, of course, given that it is a single sided motherboard and single layered also, then what happens is these are low cost, low complexity applications, and this has insertion mount components as well. It is possible to have insertion mount components, not a problem. Next is double sided motherboard. Then what happens? Then you can have components on both sides, okay, and you have wiring traces also on both sides. Okay. And how do you now connect the components on one side with the components on the other side? And that is done through what is called these vias or vias. These are holes that are filled small in diameter, and these are filled with metal, and these are used for interconnections. Okay. So, you have a motherboard with components on both sides, and then the components talk to each other or communicate with each other through these vias, which are holes that are metallized. Okay. So, we talked about single sided motherboard, we are talking about double sided motherboard. Sorry, I keep using the word motherboard, that is not again a technically correct term. Circuit board is the correct term, or printed circuit board is the correct term. Okay. It's probably one bad habit I have picked up during my Intel days, where I was part of a group whose core expertise, of course, I was part of a larger group whose main core expertise was board design. Okay. And we would call it the motherboard design, because they used to design the circuit boards for most computing products, right. And so, therefore, motherboard was a term that was used so commonly in the group that I still have that bad habit of calling any circuit board as motherboard. Okay. But again, technically that is not the correct term, even though loosely it is used many a times. Circuit board, circuit card, printed circuit board, printed wiring board, these are the correct terms. Printed wiring assembly, circuit card assembly, these are the correct technically correct terms that should be used. Okay. All right. The next one is multi-layer motherboards. So, what are multi-layer motherboards? See, the number of components on one side or both sides are so many and the number of interconnection points are so large that it is not possible to have these communications or these connections just on one layer or both layers. Okay. So, therefore, what happens is, if for such high density applications with very large number of interconnections, what is used is motherboards with more layers, and these layers are hidden. Okay. If you look at the circuit board, you will only see it is a thin card like this, or a green color circuit board, but inside these there are also internal layers through which this wiring can happen. Okay. So, these are conducting layers with copper traces that form these wirings. Okay. So, while most applications use 4 to 8 layers, some high speed computing applications can use, or aerospace applications or defense applications, they can have really dense circuit boards and definitely much more expensive circuit boards, which can use 24 to 32 layers. That is the level where we are today. Outside it looks like a a few millimeter thick circuit board, but inside you have so many layers of wiring traces. Okay. So, laminate pre-peg layers linked with vias, whatever is written in the first bullet, I am leaving it at this point, I am not elaborating, because we are going to look at each of these terms when we go to the design and fabrication and manufacturing. Okay. So, the analogy that I can give for a multi-layer board is like, if you think of your city traffic, right. You have roads on the ground, but sometimes there are so many places to be connected in so many different ways, and so many cars and buses and trucks have to go, then that just you run out of space on the ground, right. So, in such cases what do? We go for underground subways or tunnels or flyovers, sometimes different layers of flyovers, different levels of flyovers, and that is what that helps us to have multiple connections while using the same footprint. We are going vertically, we are using the third dimension. So, in printed wiring boards as well, just one surface or two surface may not be enough to connect all these components and their respective interconnection points. So, therefore, that is what leads us, or that is what necessitates the design of multi-layered motherboards, where you have different layers of these copper traces and wiring traces, or wiring traces as they are called, going through, so that all these connections can be made. Okay. And again, unlike regular road traffic where two roads can intersect, you can imagine that in a wiring board two wires cannot intersect. Okay. If you have to connect 2 points, let us say from along x axis from right to left and along y axis from top to bottom, then how do we do? If we have wiring traces on the same plane, they are all going to intersect, and there will be all the signals will be lost, there will be no connection, right. So, therefore, what do we have to do? We have to join one wire like this, another wire either above or below. So, this is what I want to talk, this is what I am trying to imply, or the analogy that I am using, I am trying to imply I am trying to underline the necessity of going for multi-layer motherboards. Okay. So, that gives us the classification of printed wiring boards based on the number of conducting layers, okay, and also where the components can be placed. So, single layer, double layer, multilayer 1. And then we also talked about single sided wiring boards and multi-sided wiring boards, okay, or double sided wiring boards. Sorry, it cannot be multi-sided because it can have only, it can be on the top and the bottom, but the internal traces are required to form all these connections. Okay. All right. So, that is where we will stop today, and when we come back in the next class, we are going to pick up from here. Okay. Thank you very much.